Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will be working on top k frequent elements. So the problem states that we are given an integer array nums and an integer k. Our task is to return the k most frequent elements. So the idea for brute force approach is we will count the frequency of each element in the input array and we will sort them based on frequency and we will pick the top k elements. So for that we need a frequency map of type integer, and let's call it frequency map equals to new hash map. And for each number in the nums, let's update the frequency map with its frequency, comma frequency map dot get or default of num default 0 plus 1. Now let's take a list and let's call it list equals to new array list, and let's pass the keys in our hash map, frequency map dot key set. Now let's sort this list for a comma b, frequency map dot get of b minus frequency map dot get of a. So basically we are sorting it in descending order. And now let's initialize a list, let's call result, and it would be of size k. Okay, now for each int I less than k I plus plus, let's update it in the resultant list. Result of I would be list dot get of I. Now at the end we would return result. Let's run the code. Oh, okay, it is accepted. So the time complexity for this would be O of n. For the frequency map it would take O of n. For sorting it would take n log n, and overall the the time complexity is O of n log n. So sorting all the elements is not necessary, and we only need the top k elements, not full ordering. So for that we need to think of an optimized approach where let's take the frequency ranges from 1 to n and we can group the numbers by frequency. So for example, let's code it up. Okay, so we need this anyways to track the frequency. Alright, now let's consider a list of type integer array. Let's call it buckets. It's a new list of nums dot length plus 1. Now for the key, for each key in the frequency map, dot keys, right? So we need key set. So let's get the frequency first. So frequency would be frequency map dot get key. So now we have the frequency. Now we will check if the buckets of this frequency is null. If it is, then we will buckets of frequency, then we will update it with a new empty array list. Okay, otherwise if it is not null, then buckets of frequency, we will add our current key. So at the end we will update it in the result. So for that we need a new list of size k, and let's consider index as 0 initially, and we will traverse from high frequency to low frequency. So for int I starts from buckets dot length -1 till I greater than or equals to 0, I minus minus, and we also need to update it with index less than k, because we need to iterate for top k elements. Now we will check if the buckets of I is not null. Okay, if it is not null, then we would update the result array. So for each num in buckets of I, we will update the result, and we will update the index and we'll update the index 2 with the current element, and if this index is equals to k, then we would break. And at the end we would return result. Okay, let's run the code. Oh god. Oh, okay. Let's submit it. Okay, it is working. So for the optimized approach, the time complexity would be O of n, because we are doing it in a single pass, and the space complexity would also be O of n because of the frequency map. So for example, let's consider this example 1, and the k value is 2. So for each element, for number 1 the frequency would be 3, and for number 2 the frequency is 2, and for number 3 the frequency is 1. So the first step is we'll build the frequency map. So it would be 1 3 2 2 and 3 1. Then we would create buckets. So the bucket index represents frequency. Now the array size would be 3 plus 2 plus 1, 6 plus 1, 7. So in the bucket, index 0 will be empty. For index 1, 3 will be updated because the frequency of 3 is 1, and for index 2, 2 will be updated because the frequency of 2 is 2, and at index 3 1 will be updated because the frequency of 1 is 3. So now 3 appears once, so it is kept in bucket of 1. 2 appears twice, so it is inserted in bucket of 2 at index 2. 1 appears thrice, so it is kept in bucket of 3. Now in the third step, we would start from highest frequency and collect the elements until k is reached here. So we'll start from highest elements, right? So bucket of 6 is empty, 5 is empty, 4 is empty. 3 contains 1, so we will add it to the result. 2 contains 2, we will add it to the result. Now that we are looking only for k equals to 2 elements, the output would be 1, 2. So in a single line, we store frequencies using a hash map and group numbers by using a frequency or using a bucket sort, I would say, and we would traverse from highest frequency to get the top k elements in O of n time. So yeah, that is it for today's problem, and I'll see you in the next one.